Hey everybody, welcome. What week are we on? This is week 11, I think. Yeah, welcome to week 11. Tonight we're going to talk about a sort of somewhat obscure branch of SuperCollider in which you can use SuperCollider to do things like drawing, animation, doodling on windows, drawing basic shapes. It is, I guess, I don't see a lot of people doing stuff like this with SuperCollider, and probably for good reason, because SuperCollider is primarily an audio programming language. It does have these features, but it's just worth mentioning and keeping in mind that uh, these functions which allow you to draw stuff and animate stuff on Windows are not really optimized for in the way that things like visual elements in processing and Adobe After Effects and VDMX and Isadora. I mean, those languages are really meant for visuals. SuperCollider is decidedly not meant for visuals, so you can't do anything that's like crazy fancy. There's no like particle generators and stuff like that. But if you're clever, you can actually get some interesting animation out of SuperCollider. And what's great is that you can also synchronize it with sound. You can have some sound playing, and it can be simultaneously playing to the speakers and also sending OSC back to the language and updating a window with some drawing and animation stuff on it. So, oh yeah, let's get into it. And hey, Beetle, how's it going? All right. So I don't even know if we're going to make any sound, but it's always worth doing a sound check just in case. Make sure we're hearing some pink noise today. I hear sound. You hear sound? Hey, Schweity. Spacetime. Hey, thank you. Wonderful. Okay, so we are going to start with a new window. And of course, it shows up down here. So I'm going to change the bounds so that it shows up on my other display. Okay, so we'll call this window draw. And I think something like 1,000, 1,200, make it 400 by 400. Lovely. Looking good. And we'll say dot front and always on top. True. Always on top. Okay. So the class we're going to introduce today is a member of the GUI class, or a member of, excuse me, a subclass of the View class. Remember View, right? View is the basic visible element. We don't use View directly, but it provides class structure for all of its subclasses like button and slider and knob. And today we're going to talk about a class called UserView. This is the item of interest for the night. It is a view. It's a type of view. It's a subclass of view. And you can think of this as sort of like the blank canvas of GUI objects. Things like buttons and sliders and knobs, they have some pre-existing way that they are drawn. They look a certain way. They have a certain a protocol for interaction. You touch it and it rotates and things like that. And then there's UserView, which does nothing by itself, but allows you to define how it will be drawn and expects you to define its entire mode of interaction using mouse key and drag and drop actions. Now, in this lecture, I don't think we're going to do too much with mouse key and drag and drop actions. So, I think you've had an assignment where you're supposed to have a key down action do that. And so in the view help file, there's key down action, should be, yeah. and there's also mouse down action, mouse move action, and these are just additional methods that you can use to define actions when a key is pressed down or a mouse is pressed down on a GUI object. But we're gonna focus on drawing lines and squares and circles and arcs and stuff like that. So UserView includes an attribute called drawFunc, which is a function, much in the same way that, like, a button's action function is a function. And drawFunc contains calls to the pen class. That's the other object of interest today. And so we tell the pen to do things, and when we refresh the window or the user view, or click and drag it or hide the window and then bring it back, that causes that means that's user view's cue to redraw itself, and in doing so it reevaluates its draw func. Well, first of all, let's just make a user view. Userview.new, its parent is the window W that we're creating, and let's make its bounds 20 in, 20 down, and we'll make it a square so that it's got a nice border all the way around. Boom. We did it. Why don't we see anything? We don't see anything because, as we just read, it does nothing by itself. User view depends on us to define how it looks, how it acts, so it's there. We just can't see it. All right. So, but in order to see it, a very simple thing we can do is give it a background color. So this ought to work. There we go. So now we can actually see our user view, and it's looking good. Now, all right, what's next? I mean, that's a great start. Actually, we can actually just dive right into the u.drawFunc. So drawFunc is a function. We have the option of passing in one argument, which is we can name whatever we want. It is the instance of UserView itself. It's this object right here. I don't know. We might use it. It's sometimes convenient to refer to the UserView's bounds in order to figure out where to draw things so that the drawing algorithm remains proportional. So anyway, but we'll keep that there. Just for starters, we're not going to draw anything. We're going to do this thing that I've been doing periodically throughout the semester. We're going to scramble the string hello and post it whenever this draw function is called. So cha-cha, here we go. And now watch what happens if we refresh the user view. So I'm just going to run u.refresh. Now nothing happens here, but we can see that the draw function has been evaluated. Whenever we refresh the window, that triggers the draw func to be evaluated. And now if we drag this window, let's see, I'll clear the post window first. And now I'm just going to drag. Nothing. No. Okay. So this is not causing the view to be reevaluated. But no. Wait a minute. I'm just wondering if we refresh the window itself. I think that should cause the draw func to be evaluated. Yeah. So yeah, the window itself is capable of being refreshed. I wonder, can we, let's start over for a second here. What if we say w.drawFunc? Is that allowed? It is allowed. Ah, interesting. I didn't know that. I think I might as well pop a disclaimer in here and say that I really don't do much with this. I know that it exists. Most of my projects do not involve drawing and animation and visuals in SuperCollider. It's something that I've toyed around with over the years. I've done, when I took a class in SuperCollider in the summer in 2010, I made a billiard ball that bounces around and makes a sound every time it hits a border and stuff like that. But I'm just gonna sort of feel it out as I go. But I'm going to stick to what I know here and just actually specify the draw function for the user view itself, which we're calling u. And we can refresh U, and that causes it. Now, this moving the window, resizing the window doesn't change the view. And that has to do with an attribute called resize. Sorry, I didn't mean to evaluate there. Resize, and we're going to set resize equal to 5. And we'll explain why very shortly. But now, watch what happens as we move the window. It's elastic, both vertically and horizontally. And the bounds of the user view are changing in proportion with the window. Maybe not in proportion, that's not the right word to use, but it's elastic. I think that's the correct term. So what if we set resize to be 4, what would this do? Okay, so now it's elastic vertically, but not horizontally. It's fixed horizontally. And if we set it to 6, then it's again only elastic vertically, fixed horizontally, but stuck to the right edge instead. So this is probably a good time to be like, okay, what are these numbers? Come on. So let's look up resize and go to the view help file. Okay, so resize determines what happens when the view's position and size. Determine what happens with the view's position and size when its parent is resized. See introduction to GUI, blah, blah, blah. So this is, resize expects an integer 1 to 9, which defines the resize behavior. So, it's like a number pad. So you can think of the outer border here as which corner or side it is sort of stuck to. And 5, it's elastic on all sides. So if we set resize to be 1, it's going to be sort of stuck to the upper left corner. I think that's the default. Must be the default. 2, it's going to be horizontally elastic, but stuck to the top middle, right? Or stuck to the left and the right. And you get the idea. So 5 is really that's the one that I use the most, because you want it to be able to resize fluidly. And just note that this works for all sorts of stuff. Let's make it 10, 10, 50, 50. Let's put it in a little bit more. So we're making a knob instead of a user view, and its resize is 5. So, ooh, look at that. It actually disappears. We don't really want it to disappear. Sometimes you don't want things to resize, but sometimes you do. Ooh. Okay. So that's just to point out that resize is a behavior defined for view, and therefore inherited by all of its subclasses. So let's get back to user view. 60, 360. Okay, so we've got our lovely view here. Let's actually do something with this draw function instead of just scrambling hello. What we are going to do, let's start by just making a line. That sounds excellent. So let's go ahead and look at the pen class. Pen is the class used for drawing on a user view. It's kind of the main reason it's there. I mean, it's not the most flexible object out there. It's really primarily meant to draw stuff on a user view. One of the most intriguing things about Pen, unlike just about every other class, is that you cannot make an instance of Pen, and all of its methods are class methods, which means that the object Pen exists as a class, and all of our communication with Pen is through the form of class messages. So we talk directly to the Pen. We could think of it as this like omniscient pen in the sky, and we say, Pen, go over here, and it goes over here. Pen, draw a line to this point, and it does. But we would never say p equals pen.new and then work with that instance. That just doesn't make sense in the conception of Pen. So it's just a class with no instances and no instance methods. It's very, very cool. So all of our commands will be like pen.this, pen.that, and we're just commanding the pen to move places. So let's make a line. Let's just look at some of the methods here. There's pen.move to. This basically moves the pen to a point. We don't see the pen; it's like completely invisible, but this moves it to a point, as a point, as if our view is a a Cartesian system with 0, 0 in the corner. We can make a line from the current point. So we move it somewhere and then make a line to another point. We can also just specify a line as 2 points, and it will draw a line between them. So let's do that. Pen.line. And now P1 and P2 here, the 2 arguments need to be an instance of a class called point. We haven't talked about point. It's in the same sort of family as like rect. You know how rect, R-E-C-T, represents a rectangle. Point represents a Cartesian point. There's basically, you can say, if we want to make a new instance of point, point.new 40, 45, right? And there we go. We've made a point. And this is a lot of stuff to type for just making a point. So fortunately, there's a really, really easy syntax shortcut, and it's concatenating 2 numbers with the @ sign. And that has the same effect. So this is 40 pixels horizontally, 45 pixels vertically. I mean, I say pixels, but it's more abstract than that. It's just a point, right? 40, 40, the point, 40, 45. Okay, so those are points. So with that, we have enough information now to draw a line. Let's draw from the point 10 at 10 to 100 at 200. All right, and let's make our window, and nothing happened. Nothing happened because we didn't tell the pen enough stuff. This is an interesting idea here, but nothing gets drawn until pen dot. Actually, even if we refresh, we still don't see anything. Even though we know that's calling our draw func, and we're saying pen.line, pen.line. Why is there no line? There's no line because we have not stroked the line. Pen.stroke. And now, boom, we just drew a line. How exciting is that? So you can see it's 10 pixels in, 10 pixels down. That's our first point. And then the target point is 100 pixels, 200 pixels down. And so we've drawn a line. And if we refresh this, it does actually redraw the line, but it's the same line, so it doesn't look any different. So we can do something like rran 200, 300. And now it's picking a new y coordinate for the second point. Yeah, so that's working. And then we can say u.animate _ true. Oh, there it goes. We've animated a line. And obviously we can just say false, and it stops animating. So that's a very basic introduction, but let's get some more pen stuff going here. Yeah, exactly, Beetle. It's very exciting. We can just say rand 0 400 at rand 0 400 comma exact same thing. So we're just gonna choose 2 completely random points on the canvas. All right, there it goes. Animate. And I think we can do u.frame_rate 20 frames per second, 15, 10, 5, 1. Yes, I think that's right. I don't know what u.animate does in the background, like what actually happens under the hood, but it must be scheduling something on app clock, because app clock is the only clock that can call GUI commands. So I think it just sort of internally says schedule this u.refresh on the app clock and repeat it this according to this frame rate. Yeah. Now the question is, how fast can you go? Let's try 60. And now what if we say u.frame rate and just get that value? It's giving us the actual frame rate. It's just like the, you know, so if we do something like 120, I think we're, my guess, yeah, I think we're basically capped at 60, which is very generous, if we're honest. I mean, 60 is pretty nice. I'm fine with 60. So just keep in mind that you can't just specify frame rate like a million. You know, there are limits here. So I think the default is 30, and that looks pretty good. Anyway, let's turn that off. Let's look at some more pen commands, pen class methods. Maybe we should draw a square. Let's draw a square. That sounds good. Let's start with pen.move to 100, 100. Then we're going to say pen.line to 250, 100. And now move line 2 has the passive effect of also moving the pen. And so first we just move the pen but don't draw anything. Then we move the pen to a new point and draw a line. And now the pen is at a different point. So now we can bring it down to the point 250, 250. And then we'll move it back over to 100, 250. And finally back to its starting point and pen.stroke. I think now we just refresh. We might need to do this. Ah, look at that beautiful square. It's right there. So there's so many things that come to mind. I mean, at least for me, as soon as I start doodling on a user view, I'm like, ooh, I can make a bunch of concentric squares or overlapping squares. But let's declare some variables here. So we'll make a variable rand minus, oh, no. Variable, we'll just call this, let's call this rand. Minus 10, 10. So, let's see. Let's also make variable x and y. And so we'll say x equals 100, y equals 100. And we'll say, we're just going to replace all these. Some parenthetical expressions. And let's see, I think there's a hotkey here. I'm seeing if I can remember it. Yes. Look at that. That's great. Command option down with a line selected or highlighted, and you can copy that line. All right. So I think this is what I wanted. No, I wanted one more. All right. We'll say x, y, x plus rand, y plus rand, x plus rand plus 250. I am not probably doing this in the most efficient way. I'm just doing it. No, I want to keep that one the same. X plus rand 250, y plus rand plus 250. What I'm trying to do here is just each time we refresh, the square will move. It'll translate basically by some random pixel amount between minus 10 or positive 10 pixels. But it's never going to be beyond a starting point of 90 or above 110. So let's see, we've started here, we moved it over, we moved it down. Now we got to move it left. Whoops. And oh, you know what I should be doing? X equals x plus rand, y equals y plus rand. Yeah, this is better. x at x, we got to put this in parentheses here, x plus 250 at y plus 250, y plus 250. Then we will 50, then we go over, we go down, go left, and back to where we started. Is that gonna work? Oh, it should be 150 instead of 250. Right, because it's the amount I want to add, not the absolute amount. Yeah, so now we animate and it jiggles around. We did it. Now I think we can dynamically change this. Oh, we can. That's nice. So animate is true and it's just animating, and we can dynamically change the contents of the draw func action. Oh, there it goes. Okay. So there's a few more things that we can do. Actually, a lot more things we can do. Before we stroke, we say stroke color and an instance of color. So now it's red. And, you know, we can do some, let's see, is this going to give us an integer? It is. I want 1.0.rand. Let's do fully random parenthesis. Yeah. So now every time it redraws, every time a new frame happens, it chooses a new random color. So now it's all flashy and colorful. I feel like there's a really lovely sound we could make to accompany this jittering square. More stuff we can do. Pen.stroke. No, not stroke. Width. _5. This is a value in pixels. Now it's 5 pixels, 10 pixels, 15, 100 pixels. Kind of cool. You can get sort of a close-up view of, ooh, this is making me nauseous. Turn those colors down. Let's make it a little softer, please. A little softer. Ah, oh, that's nice. Yeah, if we comment out this, only the X, it'll now just move horizontally, right? And if we comment out this, it'll only jitter vertically. Yeah. And, oh, here's something we can do. Okay, so instead of doing random stuff, what if we want to get it to move sort of back and forth, right? Let's just turn it off for a second. Now, there's probably multiple ways you can do this, but my instinct is to use patterns. So what if we say pseq, we'll say -20 ... +20 ... mirror. This is a method for arrays that gives us that array, and then as you can see, once it goes from -20 to 20, it switches back and goes the other way, and so it turns itself into a palindrome, basically. Inf.asStream. And now here we're going to say var, no, what are we going to do? We can, let's just change these lines. We'll comment them out briefly. And we will, can I do 2 of these? I can. Cool. I got to learn my keyboard shortcuts a little bit better. We'll say, uncomment these. And ~rand dot, oh, no, I can't call next twice. I was going to do this, but that's going to, it's going to give -20 for this one and -19 for this one, so they're going to go out of sync. So I'll just say rand equals rand.next. We're only going to call next once, and then we're going to, well, you can just keep these as they are. You can just, all right. So we've made a, let's just do that. We're not going to give rand a default value. We're making a variable rand, and we need two variable statements. We'll do it all in one. We have an x and a y. And then rand is the next value drawn from this stream from pseq, and it adds it to both of the x and the y. So I think this will move diagonally, actually. I think it'll move along the top left to bottom right. We do that. And, oh, look at that. That's exciting. All right, I'm just checking the chat here. Cool audio-visual exercise to make different simple graphics animations like this. And accompanying sounds for them. Yeah, that would be awesome. I mean, I'd love to see that. Yeah, and just I'm not really an expert or a teacher in, you know, creating visuals or sort of the theory behind all that and basic shapes and stuff. I just goof around. Like, I don't really know. And I'm curious about this diagonal line thing. I think I know which method is the source of this. We'll talk about some more pen things. We'll make a circle next. Make a circle. But first, so many things I want to do here. What am I looking for here? What is it called? Cap style. Set the line's joining style according to the defined options 0, 1, or 2, but round or square. I don't know what those are. Let's find out. So I think if we do pen.cap style underscore 0, that's the same. That's the same. That's the same. It's not what I was expecting. There's an example though. Let's get rid of that for a second and turn the animation off. This is that example. Doing here. Value. Oh, we changed the, I see there's a pop-up menu. Huh. Y.value. Huh. I am not sure why. Did I spell that right? Is it lowercase s? No, it's capital S. I don't know. Well, that's... Maybe it's just because they're all right angles. It doesn't change. Well, and.capstone. I'll have to think about that some more. I'm not sure why that isn't working. But, okay, so in addition to stroke, there is... let's make this window again. Let's get 10. Go, and let's just do the stroke color is gonna be blue. And we'll animate. And we can also pen.fill. And this is going to fill it, but we haven't set a fill color. What? Do I have to do it before stroke? Is it? Oh, is it fill stroke? Do I have to? Oh, okay. Wonder why fill didn't work. Maybe they can't, maybe fill and stroke can't be used together. Like, let me try just pen.fill. Yeah, that works. But if I do pen.stroke, for some reason fill doesn't work. What if I do this one first? Yeah, I guess this is sort of like you either fill, you stroke, or you stroke fill, but you can't stroke fill by doing two separate commands. Fine, whatever. Fill, stroke. So there you go. It's got a stroke, which is the outline, and a fill, which is the inside. Can do like we can choose black or white. Dot choose. Ah, seizure inducing. Let's do gray 0.23. Gray 0.3.rand. Okay. So let's make a circle. So these are all just lines, but we can also make arcs, and with arcs we can make circles and ellipses and all sorts of stuff. Yeah, so there's curve 2, arc 2. Yeah, I just need to sort of sit down and read these. Draws an arc of a circle using a radius and tangent points. Draws a cubic Bezier curve from the current position to the point. The one I add arc is the one I was thinking of, because there's pen.line where you just specify 2 points and it draws the line between those 2 points. Or you can move the pen somewhere and then make a series of lines from one point to the next. And arc 2 and curve 2 they move the pen from one point to the next and draw a curve. And we'll just do add arc. We put an arc somewhere. So let's I'll just copy this, and we will sort of stash this down here in case we want it. Pen.add arc. So center, this is the point corresponding to the center of the circle. We'll say, well, this is what, 360, so halfway. Here's a good opportunity to use arc. Let's use the user view argument. So let's say we just do 180, right? That's the center. Oh, we need a point. 180 at 180. That's the center point. Radius in pixels, 50. Start angle, this is radians, so we'll start at 0 and go to 2 pi. And that'll give us a circle. And then we have the pen.stroke, but let's make it pen.width like 4, and pen.stroke color dot new 0.71. I don't know what color this is going to be. Let's put all these in one thing, so that, let's save that. We don't need that right now. Down there. Okay. Hey, we made a circle. Let's just let's animate it. It's not going to do anything. It's animating right now. But let's just see what happens if we do pi. Oops, sorry. Yeah, so it starts at 0. I guess, well, let's do pi over 2. Yeah, so it starts at 0 and goes all the way to 2 pi. We can do like 2 pi minus 0.1. So almost a complete circle. We could do like the Pac-Man or something. Let's do that would be like 5 or 6 and 2 pi minus 5 or 6. No. Pi. C. Pi. I don't know. Let's just do 0.3, 2 pi minus 0.3. Is this gonna work? Huh. I do plus. No idea what I'm doing here. What about minus 0.3? I am messing this all up. Oh, you know what? We have so many windows now. Okay. Whoa, okay. So start angle, if we do pi over 2, and go to 3 pi over 2. Oh, this is not the end. This is how much of the arc we want to draw. Okay. Yeah, so it's, if I had only read the manual, it's the, yeah, the starting angle and the extent of the arc, not the starting angle and ending angle. Well, that's why. All right, so I thought I was going crazy. Pi over 6, and we want 2 pi minus pi over 3. Yeah, it's Pac-Man. Sort of. I mean, I don't really feel like drawing the lines in here. I could do that, but yeah, maybe we'll. What happens if we fill it and it's not complete? Why does pi over 2 start at the left? I think that it's consistent with standard geometry. This is the angle here is 0, and we go around clockwise. So this is pi over 2 radians. This is pi radians, 3 pi over 2, and finally 2 pi. So I don't, pi over 2 corresponds to this absolute point around the circle. Yeah, it should go upwards. That's right. I don't know. Because that's just the way it is, I guess. Which I guess is kind of frustrating. So what if we stroke fill? No, is it fill stroke? It's fill stroke. Ah, it just sort of draws a line between the first point and the last point. All right, that's as much Pac-Man as you're gonna get from me. You guys can do the rest. Now, some more stuff I wanted to do. 2, 0, 2 pi. Let me try to make this float over here and then come back over here and just yeah, let's go ahead and do that. So when we want to animate it, and we want this to drift over to the right, so we'll make a var coordinate, which is initially 180. And then I guess we need another pattern here. So let's say shift equals pseq. And we want to push it all the way off. So we'll say actually, let's start at, it's got a radius of 50, so we want it to start at -50. That way it'll be drawn completely off screen over here and the radius won't quite fit. And dot 360 plus 50, which is 410. Inf. Dot as stream. Is this gonna work? Let's find out. Oh yeah, it's X and Y. Oh, it's like the setting sun. How nice. I didn't want to make it diagonal. I just want it to be horizontal. Uh-oh. What did I do? Oh, it's because I made a new window. That's why I kept these separate. That's why I kept these separate. So now I can reevaluate this whenever I want. Let's do -48. So now it'll go twice as fast. 3 times as fast. So it's just moving over that many more pixels. Cool. Does anyone have any questions so far? I think the last thing I'm going to try to do, well, you know what? I'm also going to show there are some really cool examples in this help file. Like it's really wonderful that there's like a complex example for everything that they introduce here. There's just example after example. They're all totally worth looking at. Yeah, so let's look at a few of those. And then the last thing I'm going to do is I'm actually going to make a synth def and have it make some sound and show you all the basic construction for getting sound to be basically controlling GUI, like the appearance of a a user view. Okay, let's look at some of these examples. Just poke around. There's one that I looked at earlier today. It was awesome. No, that's not interesting. I think, let me just look for, where was it? I think it was in the user view help file. This one. Nope, 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 nope. I was trying to search for, oh my God. User, wow. What have I done? User view. And now let's do a find for semi, yes. This is the example I was interested in. It's not that long either. I just want to change the rect so that it shows up on screen. I don't have to drag it there. All right, so how awesome is that? I mean, that is pretty cool. And you know, you might be wondering how do we get this sort of delay effect on the visuals where there's like a trail behind them. It's actually very simple. It involves at the beginning of each frame, we set the fill color of the pen, and this is red 0.2, and then 0.1 is the alpha value, and 0 is completely transparent, 1 is completely opaque, and we basically fill a rectangle covering the entire screen, but it's somewhat transparent, so it darkens the existing lines. But then it doesn't obscure them completely. But as the next frame happens and another layer gets put on there, eventually they all fade away and they become this red color. And then here's an iterative loop where we are doing a pen.rotate. I think there's some pen methods which are really convenient for drawing circular things. And then we make an oval. And you know, this is all just defining the draw func. And then we create the user view and set its draw func equal to this variable draw func. So if I made this, let's make this a different color. So now it's more of a red. And if I make this 0.2, let's do window.closeAll. Let's do 5. Yeah, so now the delay effect is more subdued because the transparency layer being drawn at the beginning of each frame is more opaque. And if we do 1, there's no delay whatsoever. But if we do something like 0, I don't know why it's not red. I think, yeah, there we go. So now it's like the layer being put on top of it is almost completely transparent so that we get all this wonderful stuff. Yeah, reverb for video, exactly. It's true. It's really true that some of these examples are very beautiful and complex, and they're just like lines and curves and just basic shapes that are just drawn in different colors, and it's all sort of beautifully algorithmically determined. So that's a good one to study. I don't think there's anything too complicated going on there. Let's go back to the pen help file. See if I can find a really cool one. Let's just try this last one. Oh, that only works on transparency layer. Example. I'm trying to find a good one. Oh, this is like one of my favorites. Okay. Copy this. and change that. And this is a little bit longer. See if I can digest this a little bit. So we make a window, we set its background color to be blue. We bring it to the front, and now so here we're actually setting the draw func for the window itself, which I guess is legal, you know. And then we basically use the current date to make a random process from a random seed. And pen.use, interesting. I guess that's like a pen.use draw function, and then revert to the previous graphic state. This allows you to make complex transformations of the graphics without having to explicitly revert to get back to normal. I don't actually understand that immediately, so I might have to think about that some more. A lot of math. This looks like a processing code to me. You know, it's just a lot of numbers and addition and powers and stuff. And then there's a 1200.do. So this is creating a bunch of lines, it looks like. And anyway, it looks like this. I'll bring it up. Yeah, it's very particle generator-esque, sort of. I mean, it's just all these individual items sort of moving around and shifting. Yeah, space-time. You can ask at the end. I'm gonna try to hack my way through a sound example, a sound and drawing and animation example. Oh, and there's one more method before we do that. It is clear on refresh. This is a Boolean, that's true or false, determining whether the view should be completely cleared before redrawing itself. So let's see, do we still have our setting sun, our this animate? Let's slow it down a little bit. Okay. So if we do actually, I think I want to close this. There's, yeah, dot clear on refresh, and we will set that to false, which is not the default. And now, if we animate, it does not clear on refresh. That's an interesting effect. What would be cool is if we did maybe this. I like that. So we're just randomizing the stroke color, but only randomizing the green value. So it's always got full blue and got some. Why does the yellow clear? The yellow doesn't clear. It's just that the it's moving slow enough, and it's got this blue outline, which is obscuring the yellow. But I think if we move it like this, you'll see the yellow. Yeah, now we got some Pac-Man going on here. Closed mouth Pac-Man eating. Just smashing into stuff. Yeah, so the yellow's not clearing. It's just that if we move it slow enough, if we move it by an increment which is smaller than its stroke width, then that blue will just continue obscuring the yellow. Okay. I have an idea for a sound I want to do, a vague idea. We'll see how it goes. So we'll keep all this for now, and I'm gonna make a synth diff. Okay. Let's do just a blips, I guess. I'm not very creative with my names. Arg freak. Actually, let's do var freak big env freq equals txrand.kr. We will have this go from 250 to 4000. And the trigger is going to be dust.kr. Dust is like impulse, is an impulse generator, but we give it a density and it makes approximately that many impulses per second. And these impulses just are little 0 to 1 back to 0 transitions, so they work perfectly as triggers. Let's say 12 per second. And we'll say sig equals lftry dot ar freq 0 0.2 exclam2 env engine m.perk 0.001 and then a very quick release, just 6 centiseconds, and we'll say trig and not done action 2. So we're going to repeatedly trigger this this envelope. Let's test it out first. Okay, I'm gonna make this let's see, I'll make this a little bit less, and just for fun I want to pan it. We'll do grand kr minus 0.8 positive 0.8 trig. So a trigger also chooses a new pan value. Okay, so that's sounding more or less the way I want it to. What we're gonna do here is a send reply, and you should remember this from our OSC lecture last week. So trig, we're gonna use the same trigger, and I forget the arguments here. Trig command name, we'll say, I don't know, hi. Should give us a more meaningful name. Hi is fine. It's just the OSC address we're going to be listening on. And then values. Can that be an array? Is that supposed to be an array? I think so. An array of ugens. Perfect. That's exactly what I want. So we will send the frequency, the current frequency, and the I think that's all we need. Let's just send frequency. Thought I might have needed more stuff. Okay, and now we'll make an OSC def. Receive. This is just the name. Arg message, message.postln. Listening on address hi. Okay, good. So the last thing we really need to do here is just update the draw function. Or just no, I think we can just say shift and then okay, I'm gonna copy this. I think the idea is we may not need our pattern here, but basically every time we get an OSC message, we want to modify the draw function somehow and then refresh. So we're going to be using our triggers from our synth to basically drive animation. Rather than just saying animate true, go, we're going to wait for a trigger from the server to advance by another frame. So basically if we get a high frequency, I want to make this shift amount big, and see. I think we do need this, so we'll just keep this as is. Oh, I have an idea. Yeah, I have an idea. I think I know how I want to do this. So we know that we can say stuff like shift.nextn, 5, and we get those. And we can say, I just want the last thing. So I can say dot reverse. No, dot reverse at 0. Yeah, so it basically pulls the next numbers, but then takes the last one. So I can decide how many I want to go. So coord equals shift dot next n message at 3. This is the actual frequency value coming, and we're going to explin this from 250 to 4000 down to we might shift as little as 1. We might pull 1 number from it or 20 numbers from it. So that's it's going to be, I guess we'll round that. Okay, let's take a step back. We got this variable. This is the amount. This is basically going to determine the x coordinate of the center of the circle. And it's being equal to the next, we're going to grab the next number of values. The number of values we grab is going to be between 1 or 20 based on the frequency of the sound. So high frequencies will grab more values. And let's see, if we just do next 1, that still gives us an array, doesn't it? Good. So we're going to get that. And then we need to say dot reverse at 0. And that's going to give us, we're basically jumping ahead a certain amount in our shift stream. And I think that should work. Just want to be able to see the code a little bit. Okay. So we've got our window. We've got this. If we refresh, there it goes. Going. So now we've got our synth diff. We'll set this up to receive, and then we'll start the sound. Nope, it's not working. I should give this synth a name as well. And I think I know why it's not working. It's the classic error here, which is you cannot use this Qt. Yeah, try scheduling on app clock instead. Well, that's an easy fix. I think we just defer the whole thing. .defer. So all of the stuff that we do here, we just defer, which basically wraps it in a routine and plays it on the app clock. That's so that should work. Let's do that. Yes. I'm going to change this to be impulse, because now we'll sort of hear, and let's make this 50. So now we only get low values. Now we only get the exact same value every time. And, we could do other stuff, right? We could use the pan position to change the y coordinate. Well, let's do that real quick. That shouldn't be too hard. Let me just stop that so I can think. Let's see the way to do this. Oh, we don't even need to make a variable. We just say this is going to be message at 4. We'll eventually get that, and it's going to be dot lin. It's going to be a value between, let's say, -1 and 1, and we're going to map it to. We can even just multiply it by some value. Let's multiply it by 100, and we'll change this to be something called pan. Pan now equals that thing, and then we'll send freak pan. What is your problem? Oh, it's because I haven't defined trig yet. I have to put it after trig. Let's put it down here. There we go. So message at 4. Oh, okay. I can't just multiply it by 100. We'll do dot lin -1 1 100 to 260. Yeah, so now when it's on the left, we see it a little bit higher. I guess we can do like 0 and 360 to make it extreme. So when it pans to the right, we see it on the bottom. When it pans to the left, we see it on the top, which is sort of weird because you'd think you'd have a left-right thing. But anyway. And I should also add a density argument. This would be sort of fun. So we can say synth set dense 10. There we go. Lovely. Modern art. Lovely. Okay. Well, that was exciting. That's the gist, really, of I think that'll be what I'm gonna do, because we got fall break coming up. Is I'm just gonna do one in-class programming problem where I'm just gonna ask everybody tomorrow to make just a simple, relatively simple user view that makes visuals in response to sound. Basically using the exact same construction here. Synth-def, you make a synth, you make an OSC def that responds to a send reply. You know, so you have your synth actually sending OSC and then receiving it back in the language. And then your OSC def's action function will take care of modifying the user view's draw func and then refreshing it every time an OSC message is received. And you can make something like this. It's very exciting. Yeah. So that is going to be it. I had a feeling this was going to be kind of a shorter stream. I don't think this is an area of SuperCollider that I'm not that interested in going into the tremendous amount of depth here, nor do I really feel capable of going into a tremendous amount of depth, because I'm not a visual artist. I don't have a lot of experience, so everything I do is just going to be sort of clunky and primitive, and sort of I don't feel qualified to instruct you all. But that's the basics of Pen. So I hope you all enjoyed that. Spacetime, you had a question that you wanted to ask, so I'm done. I think I'm gonna call it a night, but I'm happy to take a question or two before I go. So ask away. If you're still there. Or if anyone else has any questions, that would also be totally cool. Yeah, you've got a window, 2 user views, both the same size as the window, so one must be on top of the other. Okay. How to make a Windows own view and each user view receive all clicks. Let me answer Spacetime's question first. So you want to have a window with 2 user views on it, sort of one, whichever one you place first goes on the window, then you make another one that goes on top of it, and you want the Windows view and both user views to be able to receive clicks. That's what you want. And yeah, no problem here. Let's take a look at that real quick. That might not be possible. I mean, okay, well, I'm glad I understood you correctly. So we have something, let's see how fast I can do this here. So we just have that and another one like that. I'm gonna give these colors. This one black, blue. Yeah, so they're all there. So if I say u1 dot visible false, there's the white one. This one's on top. And so then what we'd want to do is like dot key, no, mouse down action. So we know this works. Arg view, we'll say top view, dot post ln. I should move my, I just don't want to close it because it's so pretty. Just tuck it over here. I don't think this will, oh no! Oh, resizing it causes it to refresh. That's so sad. It's gone. Oh, let's just close it. That's a tragedy. All right. So now if we, yeah, we can click that one. Now, okay, the obvious thing to try here is mouse down action to bottom view. I have a feeling this isn't going to work. Right. Well, this might not be possible just because, I mean, what you're asking is like, how do I make it so that I can click on my code and on the Mac OS desktop at the same time? It's like you can't do that. It's not meaningful. I don't want to put my foot in my mouth here. It might be possible with some crazy weird workaround. But I mean, I don't necessarily see a need for you to have multiple GUI objects that are receiving a mouse down action. I mean, you can only click on one point at one time, right? Click, and there's no other information. Like, I mean, it doesn't make sense to say like, oh, now I'm clicking on both views. Now I'm clicking on just the bottom view. I mean, it's obscured. There's the concept of layers, which is like an inherent thing in all sorts of software, like all the Adobe products, and you can't click on the thing below it because it's got a thing on top of it. So I think the only solution would be some really funky workaround. It's like, what is it that you want to do that you can't do? It's like, I mean, you've confirmed that you've clicked the mouse, so do the action, right? I bet whatever it is you're trying to do, you can do it all with the mouse down action function of the topmost thing you're clicking on. That's my hunch. It's that it's like a programming rejiggering is what you want to do, rather than. I see a lot of questions on the listserv, which are like, how do I do this thing? And it's like, well, you're thinking about it the wrong way. This is what you need to do instead, and then your problem is easily solved. And Dongrul said, circle is continuously moving to the right. My guess is that you have animated it. For my sound example, I have intentionally not set animate to true, because when animate is true, there's an internal function just refreshing the view at a frame rate. So it's going to obviously just keep moving or doing whatever it is you programmed it to do. But for the sound example, I did not actually evaluate u.animate. I left it alone, and then I went down here, I made my synth, and the OSC def is responsible for advancing the frames. Because every time it gets an OSC message, this function is evaluated, and I wonder if that is your problem. That's my guess. Because the only way you can get the circle to move is if you're refreshing the window. And the only way you can do that is by physically resizing the window, or calling refresh on it, or having animate be true. Yes, I have u.refresh inside, because every time we get an OSC message, it redefines the draw func and then refreshes the user view, which causes draw func to be evaluated. You're welcome. Not a problem. Okay. So I hope that was fun. I mean, I think this is a ripe avenue for audio-visual experiments, and I hope you all get some fun use out of it. And maybe some of you might even want to incorporate a little bit of this into your final project. Who knows? But that's it for tonight. I think there's no stream next week because it's fall break. But then, thank you, Spacetime. Appreciate it. Let me take a look at the syllabus. I think it was like catch up, miscellaneous, blah, blah, blah stuff. All right, so we've done pen, drawing, and animation. No class next week, no stream. Oh, okay. Integrating SuperCollider with digital audio workstations. We're going to revisit patterns, and we're going to talk about different event types, because we've been making note events, but there's also MIDI events. So we can actually use pbind to generate MIDI messages, and we can internally route that to a DAW or some external MIDI device or something. So that'll be fun. And then the next week, introduction to live coding. I think I may spend a lot of attention on patterns there as well. Introduce some pattern objects which basically enhance pbind so that it's more friendly for like dynamic redefinition and reevaluation without breaking the flow of the music. And I don't know, then we'll just sort of figure out where we are. I have a feeling that I'm not really going to introduce any new topics here, because we're basically at the end of the semester and everyone's going to be presenting their final projects and probably, I assume, needing some help. So maybe I'll just do like a help stream or something. So feel free to suggest any topics or things that you would find interesting, or because I mean, to be perfectly honest, everything OSC and before, that's like everything I know about SuperCollider. It's just everything I do is within these topics. So those are the basics. Those are the essentials. Anyway, okay. Well, thank you all for watching. I'm gonna get out of here. Hope you enjoyed the stream. And no stream next week, but I will be back on 2 weeks from now, same time, same place. And see you all then. So thank you for watching. Take care.